Oh my. So we're going to work on multi digit multiplication. So your note should look like this. I spelled multiplication wrong, so that's good. So we understand, and a lot of you are doing very well with your facts, which is our basic. For example, 3 times 3 is 9. Very good. Some of you understand how the placeholder works when we have a number back here. So what we're going to do is we're actually just going to break it down even further. Okay, we've done this with our decimals, and we're going to do a little more with our decimals, but more importantly with our tens and our hundreds. So the first thing we're going to do is we're going to put 1, we'll even space it out a little bit, 2, 3. Okay, so we're going to get rid of this over here. Multiplied by 5, 1. Okay, pretty simple numbers. We should know our times tables of that. Okay, so first thing we're going to do is we're going to take apart this number right here. Okay, so we're going to bring it over here. So the way we can write this number and the way that it really is because what position is this 5 in? Someone? Tens. Okay, and this one? So we have 5 tens, which is 50. Very good. Plus 1, 1, which is 1. So we have 50 plus 1, right? You see that? Okay. So now 1 times any number is the other number, not itself. So 1 times 3 is 1 times 2? 1 times 1? Okay. Easy enough, right? So now this 5, again, what number is it really representing? 50. So I'm multiplying 123 by 50. So I'm going to drop this 1, put a 0, because it's 50, right? Now, when I do, come over here, we'll use a different thing. We'll use black again. Go 10 times 12. So I can drop this, right? The 0. And I can bring it back here, right? Are you sure?
Yes.
And then 1 times 12? Someone? 12. Right?
Right.
So what's happening is I'm just multiplying this number here by that 50. And when we do that, we're going to bring our 0 way down here. Because 0 times anything is 0, right? And we know we have 5 sets of 10, so we're just going to put that 0 here to represent that 5 sets of 10. And I think another term y'all used was the placeholder, right? Since it's a placeholder, what we're doing is we're shifting that ones position down here. We already figured out the ones position. That's right here. So now all we have to do is solve. 5 times 3, 15. Now here's where y'all get tricked up when you're doing your adding stuff. So we have 15. That means that 1 comes over here, guys. Okay? So 5 times 2 plus 1. Now 5 times 1 plus 1. Now these numbers are already lined up for us. That's why we use so much space. And you add them. Okay? 3 plus 0. 5 plus 2. 1 plus 1. 6 plus 0. Look at that pencil roll. Hold on. Let's find out. What is it? It is right. Now, we're going to throw in something in the mix. What if I took this? See this pencil? It is green blue. It's more anticlimactic than I thought. So we're going to take this pencil and we're going to add a decimal right here and right here. Now, what is my answer? Go ahead. Go ahead. Right here? You sure? You sure? What do you think? Right here? What do you think? Between the 7 and the 3? Behind the 6. Okay, so we're going to take a look real quick. Okay, we're going to take this number because our multiplication remains the same. Okay, this all stays the exact same. So we're going to take this decimal and this decimal, and we're going to count how many positions are behind it. 1, 2, 3. So how many decimals should be in my answer? So if this number was written as a whole number, which we just did, it would be 6, 2, 7, 3. And we could add our decimal right here behind the 3 to make it 6, 2, 7, 3, and 0, 0 tenths. So we're going to actually count 3 up. 1, 2, 3. So our decimal would go right here.